Have you ever thought about running a seriously powerful AI? Something like Google's latest models, but right on your own laptop? I'm talking no cloud connection, no internet at all, just raw, local processing power right at your fingertips. Well, today, that's exactly what we're going to do. We're putting it to the test with a little experiment using Google's brand new Gemma 4. And that's really the big question here, isn't it? Can your personal computer actually become its own private, intelligent assistant? A kind of second brain that knows your personal documents, your files, and can work completely offline? It's a fantastic idea, for sure, but is it actually practical right now? So why would you even want to do this? Well, the benefits are huge. First off, you get total privacy. Your data never ever leaves your machine. Second, there are no subscription fees. Once you've got the model, it's yours to use forever. And third, it works completely offline. You could be on a plane, in a cabin in the woods, wherever. It's a pretty compelling dream, but to make it happen, you need the right tools. Okay, so let's gear up. It's time to meet the AI toolkit for our mission. To pull this off, we're going to need 3 key pieces of software, all working together in harmony. So what's at our toolkit? First up is Gemma 4. That's Google's powerful new family of open-weight models. Think of this as the AI's brain. Next, we have Ollama. This is the magic engine that makes running these massive models on your own machine surprisingly simple. And finally, to actually build our application, we're using an AI coding assistant called Claude Code CLI, which will hook directly into our local Gemma model. Now, Gemma 4 isn't just one single thing. As you can see here, it's actually a family of different models. You've got the smaller E4B version, which needs about 8 gigs of VRAM. That's pretty doable for a lot of machines. But then you jump up to the more powerful 26B or the beastly 31B. And whoa, the VRAM requirement shoots up to 16, even 24 gigs. So the first big step is figuring out which model your computer can actually handle. But here's the really good news. You probably have enough horsepower for this. A recent survey showed that a whopping 75% of developers already have 16 gigs of RAM or more. So that means running these really capable but still accessible versions of Gemma 4 is already a reality for most of us. All right, enough with the theory. Let's get our hands dirty and actually build something. Our project is to create that second brain, a real AI application that can read your private documents and answer questions about them. A truly personal, local, and private assistant. So here's the game plan. We're going to build this thing in 5 main steps, and we'll use our AI coding assistant, powered by our local Gemma model, to do the heavy lifting. We'll just prompt it to write the Python code for each step. First, set up the project, then get it to load our documents. Next, turn those docs into vectors so the AI can understand them. After that, build the main question and answer function. And finally, toss in a summarization feature for good measure. So, we did it. The project was built. Step by step, our local Gemma 4 model was generating all the code we needed. But, building the code is one thing. What happens when that code inevitably breaks? This is where our little experiment gets really interesting. Our local model was about to face its biggest test yet. And this brings us to the moment of truth, the local model test. This is where all our high hopes for a totally self-sufficient AI development workflow crashed right into the hard reality of a complex coding bug. And here's what happened. An error popped up in the final code. Okay, no big deal, right? We'll just ask the AI that wrote the code to fix it. Easy. But it couldn't. After trying several times, our local Gemma 4 model just wasn't able to figure it out. It would give us vague summaries instead of actual solutions, and sometimes it would just break the coding assistant completely. Our powerful local brain was totally stumped. So when our local quest hit a brick wall, there was only one thing left to try: call for backup. It was time to see what a much bigger, more powerful cloud-based version of the exact same model could do with the exact same problem. And honestly, the difference was like night and day. It was astounding. Where the local model failed again and again, the cloud model took one look at the entire project, understood all the context, and just fixed it. It corrected every single broken piece of code. It made the entire app fully functional in about 7 minutes. It was a stunning demonstration of the capability gap that still exists. So, after all that, what's the final verdict? What did we actually learn from this ambitious adventure to build an app using a purely local AI? Let's break down the big takeaways. Here's the bottom line. Local AI is incredibly promising. For things like privacy and cost, it's a game changer. And for simpler tasks, generating a poem or summarizing a quick article, it works great. But for really complex multi-file software development and debugging, today's local models can still get overwhelmed. For that kind of heavy lifting, the raw power of the big cloud models still has a major advantage. For now. So, does this all mean that local AI is a failure? No way. Absolutely not. What it means is that it's a revolution in progress. What we saw today is just a single snapshot in time. The power and capability of these models are growing at an insane rate. So the real question isn't if your laptop can become a true AI powerhouse, but simply when.